so sorry guys for the long hiatus, but I guess this is the next course that I'm going to be teaching in the mathematics department of the Lyceum of St. Candice. So, yeah. So this theory is actually, or this video is actually just going to be our introduction to relationship theory. The thing is, I'm going to push back or might even cancel KFC theory because there's nothing really much in the way of cells, okay, or K cells. Because K cells are basically just our way of generalizing the notion of Cartesian products, or, well, maybe direct products, but mostly Cartesian products between intervals. So if we have an interval AB and take its Cartesian product with itself K times, it is a K cell. That is a K cell. So doing this product, I equals 1 to K of the interval AB, closed interval. This is a K cell. And you'll notice that if we think of AB as a length, AB, okay, this is a one cell because it's only one side. And then now if we take its Cartesian product, we get a square. So it's still A, and then this is B. Still B. There, we get a square. Because it's the same length, so it's all going to be the same measure. Okay, and then if we take its Cartesian product again with a third interval, it's still B, and then this is still A, we get ourselves a cube. Yeah, so this is a cube now. So that's a 3 cell. 4 cell is a 4-dimensional hypercube or tesseract, and so on and so forth. And the sides are always of measure A or B minus A, or absolute value of B minus A or A minus B. Okay, so that's it for the K cell, actually. And yeah, but that's not the focus of this course. So the goal of relationship theory is to abstract, to make abstractions of relationships in real life. So we're going to talk about monogamous relationships, we're going to talk about polyamorous relationships, we're going to talk about give-take relationships and give-give relationships in the context of abstract mathematics, such as, well, graph theory. Well, mostly graph theory. We're going to be using some differential equations and maybe even some topology. As you will notice in the first lecture, when we start talking about what a relationship is in the context of our subject, or in the context of our field. So, yeah, consider this as one of the grueling courses we already have here in LOSC, aside, well, track differential equations and other advanced courses here in the mathematics department. Consider this as part of one of them. So of course, as I said, we're going to be using graph theory, which is the study of a special type of mathematical structure called the graph, which is a set of vertices and a set of edges. This over here is an example of a undirected pseudograph, but you guys will study that in we'll be discussing how this applies. And I suggest you guys have a solid foundation by at least studying the first 2 lectures, or at least studying some, or understanding graph theory, even just a little bit. And since we're going to be talking about the 3 relationship problem, I'm going to need you guys to know about differential equations. Equations. So the d squared y plus beta squared y equals 0. This is a pendulum equation, or the pendulum equation. Or b squared is equal to the square root of g over c, or rather just g over c. C, the length of the pendulum, and g, the gravitational constant of the Earth. You may even need a little bit of kinematics or a little bit of high school physics to understand it. Yeah. celestial mechanics most especially, when we start discussing and expounding upon the three relationship problem and its possible solutions. Okay, so celestial mechanics. And lastly, topology. We talk about sets, open sets, and constructing topological spaces out of these relationships that I will discuss. So this introduction video will go in junction with our first lecture. So yeah, so I'm back in hiatus, and this is what I came up with. A graph theory related subject wherein we rigorously mathematically define what a relationship is. So that's it for this introduction video. I hope you guys enjoy this course, or at least have would like to enroll in it. Now, the warning, you guys would need to know these guys and their prerequisites, of course, to understand the course and what we're going to discuss in it. So I guess welcome back after the semestral break, and yeah, good luck guys in this course.